Yeah, we'll wait for a couple of minutes more. Let people join in. Okay, so let's get started, everybody. Hi, everyone. I hope you're all doing well. I welcome you all to the second session in the ISC. Hello. Yeah. Yeah. So I welcome you all in the second session of the ISC Microsoft M365 Distributed Systems Research Forum as part of the CDS MLs and System seminar series. Please join me in welcoming our speaker, Mr. Gagan Somashekar. He's a senior researcher at M365 Research Group at Microsoft, where he focuses on AI-driven cloud resilience and efficiency, with a PhD in optimizing large-scale microservices and stints at Google, Meta, Microsoft Research. Gagan brings deep expertise in tackling the complexities of cloud operations. Today, he'll present us with AIOpsLab. It's a novel framework to benchmark and evaluate AI agents for automating cloud services tasks, as AI increasingly handles operational challenges from diagnostics to fault resolution. Gagan's work addresses a critical gap, the lack of a standardized and realistic testing environment for this. AIOpsLab serves as a SWE-Bench for DevOps, enabling scalable, adaptable evaluation of AI agents in a dynamic cloud setting. So with this introduction, I present you with Gagan Somashekar. Yeah.
Thanks for the introduction, Mayank. Hello, everyone. I'm Gagan. As Mayank introduced, I'm a researcher in the M365 Research Group, where I work at the intersection of AI and systems. Today, I'll talk about AIOpsLab, a holistic framework to design, develop, and evaluate AI agents for enabling autonomous cloud. This work was done in collaboration with UIUC, UC Berkeley, IISc, and Microsoft Research. Yogesh, who has joined us today, was instrumental in shaping the vision of this project. Coming to the agenda, I'll begin by introducing the AIOps pillar of our M365 research team. After that, I'll cover the motivation, challenges, and goals behind AIOpsLab. Then I'll walk you through the design, implementation, and use cases. Finally, we'll have some time to discuss if you have any questions and future ideas, etc. Feel free to share, people who are online, feel free to share your questions in the chat, and probably I think it's best if we get to them during the Q&A session. Let's start with an introduction of our team. So M365 research is built on three key pillars: efficient AI, AI for domains, and AI ops. Efficient AI focuses on enhancing the performance of AI systems across hardware, frameworks, and models. AI for domains aims to unlock the potential of enterprise data for AI applications while maintaining privacy. Lastly, AI ops, the team I'm part of, drives innovation in AI technologies to design, build, and operate complex cloud services, delivering improvements in operational efficiency and reliability. Our group, comprising of over 40 researchers worldwide, collaborates closely with various research groups within Microsoft, like Microsoft Research, Azure Systems Research, etc., and also with leading academic institutions. Our mission is to push the boundaries of research, create product impact, and establish Microsoft's leadership in technology. We are also committed to giving back to research community through publications, open source contributions, and academic collaborations. At M365, we are running one of the largest productivity clouds in the world, and we are constantly adapting to big shifts like explosion of AI workloads, the push for sustainability, so that and the need for self-managing cloud environments. That's where the AIOps pillar comes in. We are focused on doing cutting-edge research to significantly improve our operational efficiency and reliability so that we can provide the best productivity experience possible. Our key focus areas, as you can see on the slide, are reliability, efficiency, developer productivity, and sustainability. The reliability focus area mainly ensures seamless and dependable cloud operations. The efficiency stream tries to optimize resource usage to maximize performance and cost effectiveness. The developer productivity focus area tries to help developers work faster and deliver high quality results. The sustainability stream, something that we are working on recently, tries to reduce the environmental impact of our cloud services. I talked about 4 focus areas of the group. Now I'll talk about some key challenges of one of the focus groups, the developer productivity. I'll also talk about how we are solving these challenges and briefly discuss a solution from our group. Developing cloud services typically includes design, coding and testing, but incidents are inevitable. Most of these software development life cycles require human intervention from detection, routing, diagnosis, resolution, leading to significant delays, sometimes lasting hours. Another issue is how knowledge is managed. A lot of valuable information is being created throughout the software engineering process, but it's not always standardized or easy to find, making it hard to resolve problems quickly. Customer support teams are overwhelmed with a huge number of customer cases every month, adding more stress to the system. I've also put some big numbers on the slide to convey my point in case my presentation isn't doing a good job. In summary, first there's a diverse set of tasks and artifacts from coding to testing to deploying. Then we have the large scale of repetitive activities like customer support cases and incident resolutions. And most importantly, human-driven development creates additional delays and errors. When you put these together, the result is significant engineering toil. This makes it harder to work efficiently and slowdowns are inevitable. To tackle engineering efforts, in our team, we are developing many innovative solutions. First, we have AutoKB, which automates PR generation to streamline the development process. Next is FuseBot, a real-time regression detection engine that catches issues as they happen. And there's the Intelligent Monitoring Recommendation Framework, which provides proactive insights to enhance system reliability. And coming to incident triage, we have developed Triangle, a multi-agent triaging system already deployed in Azure and M365, improving incident assignment and routing. Lastly, for root cause analysis, we have ARMA, a project that delivers automatic root cause recommendations to speed up incident resolution. Together, these tools significantly reduce engineering toil and improve efficiency in development and operations. So far, we just looked at what are the focus areas of our group and what are the challenges of one of the focus areas and what are we doing to solve them. And now we'll get to the core part of the talk today, which is AIOpsLab. Let's start with motivation, challenges and goals, and then I'll move on to design and implementation. We'll discuss a few use cases, some of them which I think are attractive to the audience, and then we'll discuss the project. Yeah.
Unmute yourself on Teams, I think.
Oh. Root cause analysis, or RCA, is a significant challenge in the AIOps domain and a critical step in incident management. When an incident occurs, RCA plays a key role in addressing and resolving the underlying issue. By identifying and addressing the root cause, we can fundamentally mitigate the problem. Take this motivating example. A hardware issue such as a high CPU temperature in the cloud infrastructure arises. While this may seem straightforward, the root cause can trigger a chain reaction of problems across the system. For example, a storage partition might fail to load, network latency could increase, or virtual machines might not launch properly. In such cases, debugging becomes extremely difficult. The actual root cause may lie in a subtle, unexpected area, making the process feel like searching for a needle in a haystack. To perform root cause analysis, we have some indicators like logs, traces, metrics from different parts of the cloud to help us do the debugging. However, these diagnostic sources can be difficult for the engineers to collect since they're scattered in different parts of the cloud, and the collected information might not be enough or even worse, imprecise. On the other side, the volume of the information collected could be so huge and the engineers may easily get lost and feel overwhelmed. In our team, we have developed an innovative solution called Flash. Flash is a workflow automation agent that enables reliable workflow execution. What sets Flash apart is its capability of status supervision and hindsight integration, making it a powerful tool for tracking issues and learning from them to improve system reliability. This is just an introduction about the topic, this work. The reason I'm talking about it is while Flash has many product impacts, there's a key challenge. As it was specifically designed for some Microsoft services, adapting it to other services requires substantial effort because there isn't a standardized interface for agent solutions. Engineers must rewrite workflows abstracted in Flash and modify the input and output schemas. This is just not an issue with Flash, but holds for most agents as they're developed for specific scenarios. This highlights an important gap in AIOps, which is creating adaptable, universal frameworks that reduce integration complexity across diverse services. As for the evaluation of RCA task, semantic-based scores seem like a promising solution. They attempt to identify semantic patterns to evaluate the root cause or mitigation actions. However, in practice, these scores often fall short. They lack the reliability to consistently identify root causes or recommend effective actions because they are limited by complexities of real-world systems. Previous benchmarks in AIOps have relied heavily on static datasets. While these datasets provide valuable insights, they often fall short in addressing the dynamic, ever-evolving challenges of real-world systems. They lack the ability to truly test the adaptability and effectiveness of AIOps agents in live, complex environments. This is where we see an exciting opportunity to make a meaningful impact. By introducing a standardized and principled framework, we can empower researchers and developers to go beyond static benchmarks. Now that we've looked at the challenges, let's look at a brief history of agents and software engineering to see the opportunities for developing a framework like AIOpsLab. So once GPT-4 came out in March of 2023, we soon realized that these models are powerful enough to be used for single shot generation, but they could be put in scenarios with sufficient tools to perform tasks autonomously, that is agents. So we started seeing evaluation frameworks like Intercode and AgentBench, which created these interactive environments that tested these models on tasks like executing OS commands or database queries. This changed massively in the 2023 with the release of SWE-Bench, a coding benchmark that tasked models to fix GitHub issues in repositories. SWE-Bench made it easy to finally evaluate agents beyond small snippets of code like in human eval. Starting March 2024, we saw a huge uprising of coding agents that were evaluated on SWE-Bench like Cognition AI's Devin and several others including Masai from Microsoft. However, one thing we have missed is that software engineering includes development and operations tasks. While the agent world has narrowed down to the code generation, operation tasks like incident management, which takes significant time and effort in the real world, seem to be ignored. If we narrow down to the DevOps space, we find a huge number of agents being developed for development and much lesser for operation. We believe this is due to the absence of a framework to design, develop, and evaluate agents for service operations. There are several platforms and frameworks like SWE-Bench, Intercode, R2E for code generation tasks. On the other hand, operations benchmarks have certain limitations. Lack of standardization. There is no standardized set of metrics, task definitions, or interfaces, making it difficult to evaluate and compare different tools and agents. They're siloed to single operation stars like CA, and they're also static in nature, like I discussed, in what they evaluate, in that they evaluate without real-world execution environment. An example could be Q&A datasets. And most importantly, they're not open sourced. So we present AIOpsLab. We designed AIOpsLab with 4 large goals: standardization of tasks, metrics, and baselines for AIOps, a realistic environment that must use real services, workloads, and agent actions, a scalable framework that can extend its applications, tasks, faults, and agents and integrate with any kind of agent. Lastly, a reliable system that provides observability across the operations lifecycle and ensures reproducibility of results. Before diving into the architecture and internals of AIOpsLab, let's see a case study of how a developer can use the framework. We hope this gives a broad picture of what AIOpsLab is before we get into the details. In this case study, we see a human interact with the AIOpsLab framework. They start a problem, access telemetry, and yeah, just to note, the user can be a developer, an agent, or traditional AIOps tool. But in this case study, it's the developer that is using the framework. The developer interacting with the framework chooses to solve a misconfiguration problem, that is a fault resulting from misconfiguration. AIOpsLab instantiates a social networking application from the popular open source benchmark called Testbed. It then introduces a misconfiguration in the user service microservice and starts a workload of HTTP requests to create posts in the application. The fault shows up as other microservices cannot reach the user service at the misconfigured port. The developer is provided with a sample prompt like the one you're seeing on the screen. AIOpsLab provides a CLI based tool to interact with this entire instantiated gym-like environment. Developers can run arbitrary commands in the CLI to solve AIOps problems. Further, AIOpsLab provides lots of APIs like get logs, get metrics that provide observability into the service. This CLI can be useful for developers to implement more problems in the framework. Here now we are seeing a developer accessing the logs of a particular microservice on the social networking application where the error logs can be seen. Yeah, as you can see, the developer could access the logs and see where the issue is actually arising from. So, now that we've looked at a demo, let's look at the design of AIOpsLab. We'll look at the design in terms of 3 roles. An agent. This could be, like I said, this could be a human developer, an agent, or an AIOps tool. An orchestrator that orchestrates all actions performed in AIOpsLab, and then thirdly, the service that has been deployed on the cloud. We fit these roles in AIOpsLab, as you can see on the screen. The orchestrator deploys a service and also instantiates faults in it using a workload generator and a fault generator. These generator can inject faults at various layers of the cloud service stack. The orchestrator provides context about problems to the agent. It sits in between the agent and the cloud. It specifies the actions available and how the service state changed as a result of an agent's action. The agent solves a problem such as detecting an anomaly, root causing the fault, or even mitigating it with a patch. Yeah, let's look at the key pieces in more detail. Firstly, AIOpsLab makes it super easy to integrate your agents and run them. As you can see on the slide, onboarding an agent takes just 3 steps. First, you register an agent, then instantiate a problem, and then let the agent solve the problem. Furthermore, the framework provides sufficient information and in-depth observability of the service, such as access to logs, metrics, and more. All of this happens via the orchestrator. We view the orchestrator as a critical piece to the puzzle of improving agents for cloud operations. The challenge is that existing DevOps tools are designed with human users in mind. In AIOpsLab, instead of simply retrofitting these tools, we design new abstractions and that are simple for agents to use, are unrestricted, but have sufficient guardrails with error propagation. We call this the Agent Cloud Interface, or the ACI. AIOpsLab makes it simple to define ACI. As you can see on the slide, you just need to add a method to our abstractions to introduce the shell tool for the agent. The doc string you provide automatically becomes context for the agent and gets integrated as a tool for the agent to use. Lastly, a key feature of AIOpsLab is its realism. We focus here on using real deployed services and injecting faults at different levels of the cloud software stack. This mimics realistic cross-layer challenges agents will face when performing real-world operational tasks. We formalize a problem as a tuple of task, workload, fault, and solution. We will look at these in more detail in the next few slides. And furthermore, each problem in AIOpsLab is easy to implement. As you can see on the screen, just define a workload, a fault, any custom evaluation procedure, and you're done. I would also like to mention that AIOpsLab's fault generator already provides several tools to inject faults across the service, including misconfiguration, code regressions, and even OS level issues. AIOpsLab supports the following tasks: detection, localization, root cause analysis, and mitigation. Detection task involves accurately detecting anomalies or deviations in service behavior. Localization task is about pinpointing a fault's exact source, for example, the specific microservice that is causing performance degradation. The root cause analysis task, as the name suggests, determines the underlying cause of the fault. For example, it could be resource contention among microservices running on the same host. The mitigation task, as the name suggests, involves mitigating the root cause effectively. AIOpsLab supports various faults across the software stack, including network, virtualization, application, and OS level. These faults span across categories such as authentication, configuration, application bugs, scaling issues, and network failures. Each of these faults can disrupt service functionality ranging from access denial to complete service downtime. The root causes of these faults also vary from misconfigurations, inconsistent state management, and lack of robust validation mechanisms, and correspondingly, the mitigation mechanisms also vary. Overall, the framework comes with a wide variety of problems and is easily extensible. Now that we have looked at the internals of AIOpsLab, let's look at how an agent integrated with AIOpsLab solves a problem. We also see how its performance is evaluated. Just to note, in the previous case study, we saw a developer. In the previous case study, we saw a developer interacting with the framework, and in this case study, we will see an agent interacting with the framework. We see a GPT-4 agent solving the same misconfiguration error that we saw in the first case study. In this slide, it will be a React agent. React is a framework where LLMs are used to generate both reasoning traces and task-specific actions in an interleaved manner. The agent selects a problem, after which the framework deploys the application, starts workload, and introduces the misconfiguration fault. The agent takes multiple actions with feedback in AIOpsLab. As we saw in the previous slide, an action could be a call to GetLogs API or the execution of a CLI command. AIOpsLab standardizes evaluation, and it reports that the agent mitigates the fault in 40 seconds after 10 steps. Agent accurately identifies the misconfiguration and patches it using a kubectl command. The agent adapts to barriers like inability to execute interactive commands. Here I would like to highlight that AIOpsLab AIOps in general needs well-designed interfaces, which we term the Agent Cloud Interface, and which should have the following features: efficient actions, not too many parameters or too many APIs. It should be flexible. The ability to run arbitrary commands in a shell made it possible for the agent to solve the misconfiguration problem. And error handling. It was most critical to provide good quality feedback to agents on execution barrier. For example, in this slide, the agent first tried to patch using kubectl edit command. The agent was told that it doesn't have access to interactive shell. Then it chose to use kubectl patch. So such feedback improves agent's ability to solve the task. Overall, this shows how AIOpsLab enables reliable, real-world, cross-service complexity and evaluates the performance of agents. Yeah.
So the tools that are available, are these specified strictly for the user, or does it sort of create tools itself?
Yeah, I think that's a good point. So right now, the framework supports a set of tools that are aligned with the frameworks that we use. For example, Kubernetes, we use Prometheus. So the tools that we provide are aligned with the frameworks, that, aligned with the components that are part of the framework. But the framework itself is extensible. So if a user wants to add a tool, as I showed in one of the slides, it would just take a few steps, and the user can integrate any tool that they want.
My question is can the agent be smart enough to
Create its own.
create their own script?
Right.
That's something.
Yeah, that's a good question. I think we've thought about this, but I think the main challenge is security. If we allow it to execute any action, I think that becomes a concern. But at the same time, yeah, that's a really good future work that would be very interesting. Yeah.
And it's got access to command line tools also.
Right.
That itself would be a bit of a security risk.
Right. Yeah, we are also thinking of that, and we are also thinking of why allow listing a few commands and not letting it deviate from those, or even we are thinking of we've started working with Infang and UIUC on safety research, because we feel to actually deploy the safety is very important. You can imagine it's a block in between that kind of controls whether certain actions are okay or not, or even if agents take some actions that are not okay, the safety block automatically takes the service back to a safe state. So these are some problems that research questions that we are exploring, but yeah, that's a good question. Yeah.
And in your experience, do you see how are there only scenarios which are well documented in the public domain, debugability and so on, that it's good at? This gets
Right.
from the framework, evaluation framework to the actual evaluation itself.
Right. Yeah, that's a good question. I think we're hoping that our collaboration with the students kind of reveals these, because the examples that we use are pretty standard and, like you say, are well documented, and it would have already seen these, so it would be easier for it to evaluate. But I'm hoping that our research and collaboration kinds of brings out scenarios that are not common. Yes, please. I think the focus was just to show a demo of how the agent interacts with our framework. I think how it does would be left to the agent developer. Here, I think we just use ChatGPT, which I think using its history and figuring it out. But I think it would be up to the developer or the researcher to put that knowledge into the model. Yeah.
I think you kind of answered the question, but just as a clarification, the AIOpsLab is basically just a framework which exposes all the states in some sense,
Right.
and interactions.
Right. It's
really the intelligence for automatically debugging and fixing has to be encoded in the so-called. You gave an example for the React.
Right. That's correct. Yeah. Thanks for the clarification. Yeah, I think that's a nice point to clarify. So it's more of a tool for agent developers and researchers than an agent itself. Yeah.
So how are you training the agents?
Here it's actually one shot, which is surprising. So again, going back to it, we are not training the agents. We are providing a framework for researchers and developers to train. Right. Yeah, correct.
But if this is the case,
I think it's not just the user interface that we are providing. We are also providing a framework with real services that are running, with real faults and observability into the service that is running. So I think that's where, yeah, it's not just that we are providing like a user interface. It's more of a set of APIs and set of interfaces through which the agent can interact with the real world system. Right.
And also they provide like orchestrated structures.
Right.
How this framework is different?
I think the way this is very specific to AIOpsLab, AIOps in general. I think LangChain, yeah, I think I can imagine somebody taking LangChain and building a framework similar to this. But yeah, I think it would be again like, yeah, they would have to do this to support tasks specific to AIOps. For example, root cause analysis. Say if you want to develop an agent to perform root cause analysis, I don't think LangChain would have on its own. Yeah, somebody can work on it, add features and support.
It will also provide a framework.
Right.
Register the agents.
Right.
How we have registered.
Correct.
Trying to understand what advantages that you're bringing in so that we can also explore the possibility. I think maybe one way to think about it is because this as a JUnit testing. Right, so you have a bunch of test cases and the system automatically runs those test cases and tells you which have passed and which have failed. Right? So this in a sense is similar to that define the fault, but it also brings in the solution side of things. Like that you can bring in a set of faults. You can bring in something like let's say LangChain and try to have it solve it. Yeah, more of a benchmarking orchestration. Yeah. Right. You have to orchestrate. You have to define what application that you're using. But here also you're saying that you are not providing the agents, but we have to bring our own agents and integrate. But then it goes back to the again orchestration as an orchestration. So that's the difference I would like to understand.
Do you have any performance of the data? How well does it, how many concurrent user requests it support? How big a current library can support?
Yeah, we have not done scalability analysis yet. Yeah, yeah, that's a good thing to explore. Yeah.
So based on what you would have tried, right? Then like, have you tried any specific model for things like config generation, things like crash analysis, things like log analysis? Did you guys try different models and see like which model works better?
Yeah, we do have some numbers for where we compare different models. I think, and we are also exploring more with Yogesh and his group. We are trying to include more faults. We do have numbers, but I think we are hoping to have more comprehensive numbers on a wide variety of faults, more set of services. I'll get to the numbers that we have for.
Another number which model was better? Config generation, for example.
I think we have a model called Flash at Microsoft, something called Flash. Yeah, I think that seems to perform best on the set of faults that we already have as part of AIOpsLab. But I think it would be too soon. It would be like, I don't think I can make a claim that that's the best model, because I think the fault library should be more extensive to make a claim like that, yeah.
So in system like this, right, how do you sort of do grounding? You know, a couple of things, like especially in a DevOps environment, it's typically like, okay, there are two kind of things. One is an enterprise kind of environment, which is sort of flat structure. In a telco kind of environment, it's a little bit hierarchical structure, right, in terms of how people do configuration. So how would you implement a grounding system that can work in a hierarchical structure? So I'm not sure if you, I mean, because I had done this and it didn't work for me. So
Oh, okay. Yeah.
So essentially, right, like what happens, especially in telco environment,
Mm.
you have people doing configuration at multiple levels.
Mm.
And how do you make sure you restrict the agent to not do this versus that? Yeah, just like statically this works, that doesn't scale.
Yeah, I think that's a very good point. I think that's one of the goals of our framework. Say, for example, if we could integrate a telco service of that complexity where multiple levels of configuration is needed, and I think that would enable the framework, enable researchers to use the framework to come up with a solution. So I think again, like going back, Yeah, going back, yeah, we've not tried, yeah. I think the goal is more to provide frameworks for people to come up with agents that can solve complex. So,
How are you dealing with the context window because the logs file can be very large?
yeah, that's a really good question. I think we are working with another research group inside Microsoft where we are trying to get context. The project is called Contextify, and the goal is to extract context out of the data and give that to the agent instead of passing the whole log. Or you could say, in simple words, I think summarize the traces and content to the agent. Yes. Right. 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 Yeah, I think again, I think the responsibility would go to the researchers or the developers of the agent to decide how to do it. But I think a good question. I think what we are hoping is to improve developer productivity by helping researchers develop agents that take away manual tasks or time-consuming tasks from the developers. Yeah, we are hoping to make developers more productive. Yeah, that's true. I think I don't think like not just this project. I think we've seen multiple efforts to develop agents to automate tasks. I think it's very rare that even 70% is considered a big success. 70% accuracy on different tasks is considered a very good success because that kind of saves time for developers to get involved in other tasks that are more creative.
Yeah, I could answer this. Rather than saving, right? I mean, yeah, we recently saw the Heathrow Airport, like where things went down, like that resulted in hundreds of thousands of flights getting delayed.
Right.
And in my experience, I have created such problems in places. So now live debugging in a system which takes 6 hours to could be reduced to 30 minutes, that's going to have a significant impact
Right.
on the overall availability.
Right, definitely. I think time to mitigate, time to detection are all metrics that we care about.
Rather than replacing, right?
Yeah. Right. 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 Correct. Definitely. Yeah. Right. Yeah. They get to work on more exciting and difficult. Right. Yeah. Thanks.
So I guess to answer that question, you have to come up with test cases
Right.
in which automation, that is rule-based automation versus AI-driven problem solving is better, right? So that will answer all the.
Yeah, I think, going back, I think the work that we have is to add the complex scenarios that you talked about to the framework so that people who are developing agents can evaluate whether their agents can do it or not. Or like even know, okay, at this point, these are problems that agents cannot solve. So we out of scope for agents, and this is where humans will deal with it. So, but I think our work is more of adding those complex problems into the framework than working on the agent to solve the problems. Right. 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 Yeah.
So secondly, I think it's they have a bunch of work that happen the same. That is doing exactly the internal work.
Yeah, I think Flash is also. Yeah. Yeah.
There are a bunch of these
Yeah.
thousands of these case reports from Azure that they have trained it on. So that's another problem.
Yeah. Yeah.
But the earlier one, again, sorry, this is again.
Yeah, definitely. This was the hope. So please, yeah.
One thing is to actually even use the same framework to put a human being against an LLM. Right? You give the same interface to an LLM agent and you can see who does the synchronous task. This could be like a sandbox for testing.
I would say that you bring the human into the loop so that it can both can work together to make the tools efficient and testing.
Your case point is to do an A/B test.
Yes, you need the validation, A/B test.
Yeah. Correctness versus speed and so
Who
on.
wants to take it?
I don't see the speed will definitely be system. It's a mission. From the evidence point of view, the correctness point of view, you make a system driven, mission driven stuff. At many times it goes into your loop. I've seen, right? I mean, like most of the time it works, and one time it goes. Once it goes in your loop, it never comes out of that. So now, if you're looking at 100% correctness, is human, but speed definitely.
This is a future interview for a service.
Right. Yeah, I think that's a really good point. Like I said, we have a project called Contextify. I don't know, Yogesh, if you got to work with them, Pedro and team from Azure Systems Research while you were there. Okay, so that I think kind of tries to do that. I think their fundamental belief is service can be defined by a state, and when an incident happens, service enters a particular state, which could be like a signature. And how do you get it to a state or a signature that is okay or tolerable? Yeah. So I think that's a very, very good point, and a different project, but a lot of work is going on in that area. True. I think they have. Right. Yeah. Yeah. Thanks.
So maybe I'm going to
Yeah.
as a moderator, I'm just going to give that token back to you. Then you complete your
Yeah. Yeah. Sure. Yeah, I think I'm mostly done. I think most of the I think I can comfortably wrap it up. So thanks. It was a really nice discussion. Yeah. So yeah, I think coming to an important question, how do you deploy AIOpsLab? And I think Aditya is probably concerned about this slide because he's been working on deploying it. So yeah, currently we support two ways: local deployment, where kind is used to run a simulated Kubernetes cluster on your local machine, and cloud deployment, where a Kubernetes cluster is created on the cloud of your choice. We also provide Ansible and Terraform scripts to support automatic deployments. Now that we've seen what AIOpsLab is, let's look at the use cases of it briefly. I think for half of the questions, my answer was the work needs to be done by the agent developer or researcher. So yeah, like I said, we are providing a framework to improve agents for performing AIOps tasks. And yeah, the first use case is AIOps agents and tool developers. They can use the framework to build, improve, and evaluate AIOps agents and tools. Generative AI researchers, I think like one of you pointed out, can use the framework to benchmark their foundation models' ability to perform AIOps tasks. And service owners, they can use the framework to benchmark various AIOps agents and tools and analyze the various metrics that the framework provides to choose an agent or tool that best fits their use case. And I think like something along the lines of what Yogesh said, another use case for service owners would be training on-call engineers and DRIs, basically give the framework to humans. And currently, engineers learn to perform reliability and operation tasks through shadowing other on-call engineers. The framework would be a good exercise for engineers to get their hands dirty in a safe and controlled environment where they can perform different tasks like detection, localization, and also analyze the rich telemetry that the framework provides. Lastly, cloud platform owners. They can integrate components of AIOpsLab to enhance the platform. I think the rest of the slides are more, I'll go with this slide, but I think, yeah. I think this is what you've talked about, the agents, researchers and developers using the framework to develop agents that perform different AIOps tasks. I think the next few slides are pretty focused for product groups and Microsoft internal researchers. So I'll skip them in the interest of time. And then yes, like I said, we are collaborating with systems and cloud researchers at Microsoft who are using our framework to research on reliability and efficiency problems. Like I said, Contextify is one of the problems that we are working on. We are also talking to external customers through industrial engineering services and AI sales teams who would like to use our framework to improve reliability of their services. We are also collaborating with academic institutions to enhance the generalizability and onboard more agents into the framework. I think many of you pointed out the framework is truly useful when it has complex faults, services that are close to real world services, and workloads that are similar to what we see in real world. So I think this is where we are hoping we can collaborate with academic institutions and improve the generalizability of the framework. We're currently collaborating with UIUC, IISc with Yogesh. We also have collaborations with Xinhua and Nankai. So to summarize, we have built AIOpsLab, a standardized, realistic environment, scalable and reliable framework for designing, developing, evaluating an AI agent for enabling autonomous clouds. In this talk, we discussed, we briefly introduced a AIOps team that's part of the M365 research group. Then we discussed motivation, challenges, and goals. We also discussed architecture and internals of AIOpsLab and went through case studies. We also discussed target users briefly, and we had a very engaging discussion over the project, which was very nice. Please check out the website for more information. The work got accepted at SOCC as a vision paper last year, and it got accepted recently at MLSys as a full paper. Yeah, this is the version of the paper that got into MLSys. And I think, yeah, this is a generic slide for a wider audience, but I think the first one goes to this group. And if you want to collaborate, if you want to use the framework for improving your agents, anything, please reach out to the TL. And yeah, thanks a lot for attending the talk. Thanks for all the discussions. Yeah. I think when we started with the design, it was supposed to be very agnostic of the tools that was part of AIOpsLab. But I think since all the services that we currently have are, so by design it is not restricted, but I think by implementation it is in a way restricted. So while implementing, because we had Kubernetes in mind, we wrote it with the assumption that it will always be deployed on Kubernetes. But so the change would be more at an engineering level than design level. At design level, it is still extensible. That's a good question.
Coincidentally, we have IT-Bench folks doing a talk this week.
Oh, okay. Oh, wow.
So that's another product of IBM research.
Right.
So it just happened back to back.
Right.
How does the AIOpsBench contrast with IT-Bench?
I think, yeah, definitely. I think IT-Bench is more extensive, supports more areas. I think they also support FinOps, finance operations, and SREs, and I think one more stream. But ours is mainly focused on SREs and DevOps. And even in terms of number of problems, I think they do have more number of problems. In the open source version, I think there's still 10 to 15, similar to ours. But I think in the paper they report that they have a lot more. And I think one other additional feature that they have is they have an evaluation of, I think, leaderboard where they hide some problems and evaluate your agents on it, which I think was something we were planning to work on, but we never got to it. So yeah, I think it's a really nice work, and yeah, I went through the paper, and I'll probably watch the talk too. Yeah.
Next Friday would be
Oh, nice. Nice.
DMZ. If there are no more questions, let's thank Dylan.
Thanks, everyone.